Okay, so specific heat, we are going for the interpretation of isothermal process, right? And we came to know in the last class regarding the PV indicator diagram, yes or no? So what we have got in the last class, that if we try to calculate slope, got it, of the PV indicator diagram of isothermal process, we came to know that slope was minus P by V, yes or no? Now let's try to understand what will be the specific heat. What will be the specific heat in case of isothermal process? Specific heat. You know very well that specific heat is given by C equal to Q by M del T. M del T. Got it? Del T is known as the change in temperature. But you just tell me one thing, in case of isothermal process, is there any change in temperature? No. Temperature should remain constant or not? This is the expression of specific heat. Okay, C is known as the specific heat. This specific heat may be of two types, as I have already mentioned before also. Got it? C may be Cp and Cv. Cp is known as the specific heat at constant volume. Cv means the specific heat at constant. Cp means specific heat at constant pressure, and Cv means the specific heat at constant volume. Is that clear? So C means the specific heat Q by M del T. For isothermal process, change in temperature should be always equal to 0 or not? Why? Temperature remain constant. So there is no change in temperature, right? Therefore, what should be the value of specific heat? Q by, this term will be 0. So I'll be getting 0. Q by 0, it means specific heat will be infinite value for isothermal process. Please keep it. Please. Right? I hope you understood, right? Okay. Now see, when we have learned about the mechanical properties of solid chapter, during that time I have mentioned a term over there. The term was isothermal elasticity. Do you remember? Yes or no? Since we are dealing right now with the isothermal process, so I'm going to mention again that very particular term, isothermal elasticity. What we have got? It was denoted by E theta or not? Yes? And isothermal elasticity, E theta was always pressure P. Do you remember? Isothermal elasticity is always given by the pressure of the gas P. At NTP, NTP means normal temperature and pressure. At NTP, isothermal elasticity will always take the value of atmospheric pressure, which is 1.013 into 10 to the power 5 Pascal. So please keep in your mind, since we are discussing about isothermal process, got it, under isothermal process we will be getting an elasticity value which is known as the isothermal elasticity given by E theta. We have already done about this topic before also. Yes or no? And we came to know that isothermal elasticity is always given by pressure of the gas. Now at normal temperature and pressure will be always atmospheric pressure, right? Got it? So isothermal elasticity will always take the value 1.013 into 10 to the power 5 Pascal. Please go for the next interpretation. Just put star mark below and write this. Very easy, okay? Easy or not? Done? Done? Let's go for the last interpretation under isothermal process. The last interpretation is, right, first from the first law of thermodynamics. From the first law of thermodynamics. From the first law of thermodynamics, we have what was the first law of thermodynamics? It was del Q equal to del U plus del W. Yes or no? This is the amount of heat. Got it? This is a change in internal energy and this is a change in work done, right? Now you just tell me one thing. When we have learned about the heat, internal energy and work done, we have learned that internal energy was the quantity which depends on temperature, right? I also gave you a chart, got it, which indicates that internal energy del U, change in internal energy del U, it will be positive only when the temperature rises up. Yes or no? And if the temperature of the system falls down, internal energy will be negative or not? Now, under isothermal process, what we have got? The change in temperature is 0. Got it or not? Change in temperature is 0. Therefore, del U need to be 0 or not? Because internal energy, change in internal energy depends on change in temperature, right? Thus, for isothermal process, under isothermal process, first law of thermodynamics can be reduced to del Q equal to del U will be 0 in this case, so I can write del W. So if the process is isothermal, keep in your mind, change in heat will be always equal to the change in work done. Is that clear? Clear to everyone? This is the interpretation. These are the interpretation under isothermal process. I hope you understood, right? Please note it down. Over. Please go for the next important process, adiabatic process. Adiabatic process. Okay, what is adiabatic process, by the way? I have already explained what is adiabatic process. The process in which no exchange of heat occur between the system and the surrounding. Yes or no? It means one thing is confirmed, that under adiabatic process, change in heat need to be 0 because no exchange of heat occur, right? Yes or no? So just write, it is a process in which there is no exchange of heat between the system and the surrounding. Heat between the system and the surrounding. Is that clear? You can simply write that is del Q equal to 0. Del Q is equal to 0, right? See, when I started a chapter thermodynamics, we have learned that we have got 3 important variables which can determine the behavior and character of a gas, right? What were they? Pressure, volume and temperature. And we also came to know that if pressure remain constant, the thermodynamical processes is known as isobaric. Volume remain constant, we call it as isochoric. Temperature remain constant, we call it as isothermal. Right? What will happen in case of adiabatic? Do any of the variable remain constant in adiabatic? The answer is no. Are you getting it or not? Pressure, volume and temperature will be changing in case of adiabatic process. Only there will be no exchange of heat between the system and the surrounding. So what you can mention here is that P, V and T changes. Understood or not? P, V and T changes. Only del Q is equal to 0. Change in heat will be 0 in case of adiabatic. Is that clear? And please keep in your mind one thing, out of all the thermodynamical processes we have got the 4 thermodynamical processes now. The fastest process is the adiabatic. Understood or not? So adiabatic is the fastest process. Fast, I should say. Got it? Or we can write fastest thermodynamical process. Fastest thermodynamical process is the adiabatic process. Got it? Is the adiabatic. And which process is the slow? Isothermal. Do you know what is the reason behind it? The reason is that in case of isothermal, alright, temperature remain constant. Understood or not? In case of isothermal, temperature remain constant. So it takes, lots of time to exchange a heat between the system and the surrounding. समझ में आ रहा है कि नहीं आ रहा है? But adiabatic, in case of adiabatic, it occur very fast and quick. Got it or not? You only need to keep in your mind the slow process is the isothermal, the fastest process is the adiabatic. Is that clear to everyone? Okay. Now, when we discuss about the isothermal process, what were the points which we have done? First, we have calculated the equation of isothermal process or not, and we got the equation to be PV equal to constant. For initial and the final state, we can write the equation of isothermal process to be P1 V1 equal to P2 V2. Same as like that, we are going to find out the equation of adiabatic. But I'm not going for derivations here. It's a very lengthy one. Since derivation is not important to you. Are you getting my point or not? So we are going to write the equation of adiabatic process. Equation of adiabatic process directly. You please go for the star mark and write equation of adiabatic process. Equation of adiabatic process. Equation of adiabatic process. Right? So what will be the equation of adiabatic process? PV to the power gamma is constant. You only need to keep in your mind this one. Since you are not a board student, right? Derivation is not important. Are you getting it? Have you understood or not? PV to the power gamma is equal to constant. What is gamma here? Gamma is the ratio of specific heat of gas. Gamma is basically given by Cp by Cv. Keep in your mind always. Is that clear? See, I can manipulate this expression again. The expression is in the form of P and V or not? I can bring the expression in terms of volume and temperature also. Got it? I can also convert the expression in terms of pressure and temperature also. Right? So how can we convert it? Let's understand. Understood or not? Below you just go for a line. We have PV equal to nRT. Understood or not? PV equal to nRT. So what I can write over here? P can be written as nRT by V. Can I write in this way? See, this is one of the equation we got. Okay, I'm just trying to manipulate this expression into different form. So can I write P equal to nRT by V? Therefore, in this equation, if I substitute this value here in place of P, what I can write? I can write here as nRT by V into V to the power gamma equal to constant. Can I write like this? Or try to understand, see, N into R. N is the number of mole. R is the universal gas constant. Both are constant or not for a particular gas, right? If I send this NR towards the right hand side, then I can write here T, V to the power gamma. If I take this V, got it? In the numerator part, can I write here V to the power gamma minus 1? Because if I take this V up, I can write V to the power minus 1 or not? V to the power gamma into V to the power minus 1 will give you V to the power gamma minus 1? Yes or no? It can be written as constant. Is that clear? This is also one of the expression. This is in terms of temperature and volume. I hope you understood. I hope you understood. Please note it down this one. Done? Okay, let's go for one more interpretation. Same to same process. Also, Can I write here PV equal to nRT? Now let me just find out the value of V. V can be written as nRT by P, yes or no? Therefore, in the main expression of adiabatic process, PV to the power gamma equal to constant. Can I replace the value of V as, in place of V, can I write nRT by P to the power gamma equal to constant? Yes or no? So now you just see, N into R, again it is a constant term. So if I break it down, will I be getting nR to the power gamma? And if I send nR to the power gamma towards the right hand side, constant by constant will give you constant again. So what I'll be getting ultimately P into T to the power gamma by P to the power gamma, because I have already sent nR to the power gamma towards the right hand side and I'll be getting constant over here. Yes or no? So ultimately what I'll be getting here, P, if I take this P to the power gamma in the numerator part, I'll be getting 1 minus gamma into T to the power gamma. Yes or no? Equal to constant. This is also one of the expressions. Is that clear? P1 minus gamma and T to the power gamma. Right? Go for next, PV indicator diagram. PV indicator diagram. PV indicator diagram. Got it? So try to understand. Yesterday also we have gone for the PV indicator diagram for the isothermal process, right? For adiabatic process, the graph seems to be little bit similar, okay? It depends upon the curveness. This is P and this is V. For adiabatic also, the graph is in this way. For isothermal, it was little bit steep. Understood or not? Here also same thing. If I want to find the slope, I'm drawing a tangent line over here. Got it? With respect to the horizontal, it is making some angle theta. Understood or not? This is the PV indicator diagram under isothermal, under adiabatic process. Got it? And if I want to find slope, just look at here at first. If I want to find slope, slope is your dp dv. Got it? Which is your tan of phi. Same to same, which we have done yesterday. Tan of phi. But here, yesterday we got p by v or not? Here, minus p by v, right? Here we will be getting minus gamma p by v. Now how it came, I'll be just going for a little bit calculations here. You please note it down at first. सेम सेम मीन्स यहाँ पे थोड़ा सा स्टिफनेस होगा, थोड़ा स्टिफ होगा. ना कोई दिक्कत नहीं, ऐसा क्वेश्चन आया गया पहले, राइट? Done. Okay, see, same to same process. Yesterday we have taken the equation of isothermal, right? Since we are going for the calculation of the slope of adiabatic, so I'm going to consider the adiabatic equation. PV gamma is equal to constant. Got it? Let me differentiate now. What I'll be getting? P dV to the power gamma plus V to the power gamma into dP equal to 0 or not? Differentiating, okay? Now you just see P dV to the power gamma. What I'll be getting? Gamma V gamma minus 1. But here again I'm getting dV. Understood or not? Plus V to the power gamma dP. I hope you understood, right? Now you just see, you just take this term towards the right hand side. So I'll be getting over here gamma P V to the power gamma minus 1 into dV equal to minus of V to the power gamma dP. Is that clear? So I'm bringing this v to the power gamma towards the left hand side, and I'm taking this dv towards the right hand side. So what I'll be getting, gamma p v to the power gamma minus 1 by v to the power gamma equal to minus, I'm getting dp by dv or not? Got it? Will I be getting this? So ultimately what I'll be getting here, see here v to the power gamma into v to the power minus 1 or not? Yes or no? Here v to the power gamma, see, I'm just writing over here, okay? Gamma p v to the power gamma minus 1 can be written as v to the power gamma into v to the power minus 1. Can I write like this? Whole divided by, we already got v to the power gamma in the denominator section, right? Is equal to minus dp by dv. I hope you understood, right? V to the power gamma, v to the power gamma get cancelled out. V to the power minus 1 can be written as gamma p by v equal to minus dp by dv. What is dp by dv, by the way? dp by dv is known as a slope or not? So ultimately what I got, slope is equal to, if I take this minus towards the left hand side, minus gamma p by v. I hope you understood. Got it? So for isothermal process, slope of PV indicator diagram always give you minus P by V. For adiabatic, it always give you minus gamma P by V. Is that clear? If you want to note it down, you can note it down. Done? Done or not? Go for next. Specific heat. Specific heat. Over now, the last part. Over. Okay, okay. Note it down. I can wait. Over here. Here. I hope you understood, right? How it came? Okay. Shall I proceed? Specific heat here. Just couple of minutes back, I told you specific heat is your del Q by M del T. Yes or no? For adiabatic process, what I'll be getting? Del Q will be 0, no? There will be no change in heat, right? Therefore, what should be the specific heat value? 0 by M del T. Yes or no? So what I'll be getting? Specific heat is always 0 for adiabatic process. For isothermal, specific heat was infinite. For adiabatic, specific heat will be 0. Is that clear? Done? After the specific heat, let's go for the work done. Work done under adiabatic process. Work done under adiabatic process. Right? Now see, work done under adiabatic process. Here also I am not going for a calculation, long derivations. Right? But I told you already, whatever work done expression we got in the beginning, work done as integration of V1 to V2 PdV. I told you that I am going to use this expression for every thermodynamical processes, right? For the adiabatic also I am going to use the same expression. Understood or not? See, the format is same, okay? The way which I have calculated work done for the isothermal, got it or not? Same to same I am going to calculate for the adiabatic. Only I need to change the equation, that's all. In isothermal process, we use the isothermal equation or not? PV equal to constant. T was constant, right? Here I am going to use the adiabatic equation, PV to the power gamma equal to constant. Understood or not? So work done, the main expression of work done is for expansion V1 to V2 PdV. right? Here if I consider the equation PV to the power gamma equal to constant, understood or not, and if I replace here the value of P from that equation, right, ultimately what I'll be getting, I'm not going for calculation or derivations here, okay? Work done under adiabatic process will be P1 V1 P2 V2 by gamma minus 1. This is the expression which I'll be getting, where gamma is the specific heat of gases. Got it? For competitive exam, you only need to remember this expression. I hope you understood, right? Got it? Please note it down. Over not? See, this expression can also be written in terms of temperature. This is in terms of pressure and volume or not? We know very well from the equation of state PV equal to, for 1 mole of a gas, I can write PV equal to RT or not? PV equal to nRT, right? For 1 mole of a gas, can I write PV equal to RT? Then P1 V1 can be written as R of T1. P2 V2 can be written as R of T2. Can I write like this? So if I replace the value here in place of P1 V1, then I'll be getting work done under adiabatic as R of T1 minus R of T2 by gamma minus 1, yes or no? This can also be written as, if I take R as common, T1 minus T2 by gamma minus 1. This is work done under adiabatic process. I hope you understood, right? Please do fast. I am going to complete the entire process by today. Done? Done or not? Okay. These are the important terms, and please keep in your mind one thing. Isothermal and adiabatic process are very, very important in this chapter. Got it? 70 to 80% of the questions are coming from this part only. Sometimes they are giving questions from the isobaric and isochoric. Understood or not? But we are going to complete each and every term, okay? Understood or not? Since we have completed isothermal and adiabatic, let's proceed to the isobaric now. Isobaric process. Isobaric process. Done? Now you just see, what is isobaric, by the way? Where the pressure remain constant. Pressure need to remain constant, right? That's called isobaric. You can simply write a statement, a short statement. Thermodynamic process where pressure remain constant. Thermodynamic process where pressure remain constant. Where pressure remain constant. Right? It means P should be constant, right? Yes or no? Thus, how to find out the equation of isobaric process now? From equation of state only. Every equation can be calculated from the equation of state. Got it? Thus, from equation of state, what was the equation of state? PV equal to nRT. Are you getting it? P is a constant or not? So what I'm doing, I'm just keeping V over here and I'm bringing the T towards the left hand side. So I can write V by T equal to, can I write NR by P? N is the number of mole for a particular gas, it will remain as constant. R is the universal gas constant and P is the pressure, which is again a constant under isobaric. So can I write V by T equal to constant? This is the equation of isobaric process. So if I consider the initial state and final state, let me assume that the gas has got V1 as volume, T1 is temperature in the initial state, and V2 as volume, T2 is temperature in the final state. Then what can I write? Also, this expression can be termed as V1 by T1 equal to V2 by T2. Understood or not? This is the equation of isobaric. Please. Done? Okay, since we have calculated the equation under isobaric process, got it or not? Let's try to calculate. Go for the interpretation. Go for next interpretation. Just put stomach and write work done under isobaric process. Work done under isobaric process. Work done under isobaric process. Right? So try to understand what will be the work done. Simple, okay, very simple. See here, we know very well that work done is always given as P into del V. Yes or no? I'll be getting the total work is P into del V, where del V is the change in volume. Can I write here P into del V as V2 minus V1, where V2 is the final volume and V1 is the initial volume? Are you getting it or not? Here P is constant, okay? Are you getting it? If P remain constant, then can I use the equation of state? We know very well PV equal to nRT. If I write over here change in volume P del V, got it? Then I'll be getting here change in temperature nR del T. PV equal to nRT or not? P is constant here, okay? So in place of P del V, can I write over here nR V2 minus V1 can be written as T2 minus T1, because V2 minus V1 is the change in volume, T2 minus T1 will be the change in temperature. PV equal to nRT, right? Are you getting it? P del V is equal to nR del T or not? Now I can write the expression as nR of del T. Same to same. Got it? So work done under isobaric process is given by nR del T. nR del T. Got it? Next you go for specific heat. Specific heat. See, in case of isothermal and adiabatic, we have used directly the specific heat as C or not. But right now we are coming to isobaric. Isobaric means what? Constant pressure. Then the specific heat will be converted to specific heat at constant pressure or not? I already told you that specific heat are of two types, Cp and Cv. And we are discussing right now about what? Isobaric, constant pressure. Then the specific heat need to be termed as specific heat at constant pressure or not? Are you getting my point? So we already has got the expression. You will be getting all those in the chapter kinetic theory of gas. Got it? The expression of specific heat at constant pressure and the specific heat at constant volume in terms of degrees of freedom. Understood or not? So you just write specific heat, just write specific heat at constant pressure is given by specific heat at constant pressure is given by F by 2 plus 1 into R, where F means the degrees of freedom. Got it? Degrees of freedom. I can use this expression, try to understand, I can use this expression to find a specific heat at constant pressure for monatomic, diatomic and triatomic also. Got it or not? For example, for monatomic gas, degrees of freedom is 3. For diatomic, 5. In this way, I can replace the value depending upon the demand of the question. Is that clear? Got it? Once your KTG will be over, kinetic theory of gas will be over, got it? Everything will be clear. Understood or not? But right now we are using all those terms which we are going to get in kinetic theory here itself. Is that clear? So we have calculated work done. We have calculated specific heat. Let's go for the modulus of elasticity. Got it? In terms of constant pressure. Just write modulus of elasticity. Modulus of elasticity. Got it? Modulus of elasticity. Now what type of modulus of elasticity we need to use here? Since we are dealing with gas, understood or not, we need to use Bach modulus. Got it? I cannot use the Young's modulus. Young's modulus will be in terms of length. Na? The strain need to be longitudinal strain, right? Since gas has got volume or not, so I'm going to use what? Bach modulus. Is that clear? So modulus of elasticity, we know that, what is the expression of Bach modulus? B equal to minus del P by del P into V by del V or not? This was the expression, right? Del P into V by del V. This is the Bach modulus expression. Yes or no? For isobaric process, is there any change in pressure? Change in pressure is constant. It means change in pressure need to be 0. Sorry, pressure is constant. It means change in pressure need to be 0. Yes or no? Therefore, your Bach modulus can be written as 0. Are you getting my point? So, what will be the modulus of elasticity under constant pressure? 0. Done? Let's go for the last interpretation. Just write first law of thermodynamics. Let's try to understand under isobaric process, constant pressure, what happened to the equation of first law of thermodynamics. Is that clear? First law of thermodynamics. We have, what is the first law of thermodynamics? Del Q equal to del U plus del W, yes or no? Right? So under constant pressure, let's understand what will be the value of del U. Here, what will be the value of del U? Del U has got an expression. See, del U has got nothing to do with pressure. Understood or not? Del U has got an expression N CV del T. I gave you yesterday. CV is the specific heat at constant volume or not? Are you getting it? In place of CV, if I want to convert CV in terms of degrees of freedom, what was the expression? Cp is F by 2 plus 1 into R. CV will be F by 2 into R. Is that clear? So N, I can write F by 2 R del T. I think I gave you this expression also yesterday. Right? Okay. I got the expression of del U as N F by 2 R del T. Also, under isobaric, just couple of minutes back we got the work done under isobaric. What was that? N R del T. This was the expression we got. Yes or no? Now, from first law of thermodynamics, FLTD, Got it? FLTD is a short form, okay? First law of thermodynamics, right? From FLTD, what I can write? Del Q equal to, what is del U by the way? In place of del U, can I replace the value F by 2 R del T? Yes or no? Here can I write in place of work done as NR del T? Got it? Can I write like this or not? Please keep your eye on board at first. N into R del T, NR del T. I can take NR del T as common. Then will I be getting F by 2 plus 1? Yes or no? Will I be getting F by 2 plus 1? So ultimately what I'll be getting, del Q is equal to NR del T. Got it? I can write over here F plus 1 by 2. Got it? This is also one of the expression of, this is one of the expression under first law of thermodynamics. Got it? Which reduce under isobaric process. I can manipulate this again, but please note it down till this much. We can manipulate this in terms of gamma also. Done? Please do a little bit fast. We are running out of time. Okay, I have gone through the syllabus, okay? Heat engine, refrigerator, everything is omitted from the syllabus, yeah? This one, this one, this one, last one, last one. Here it's, oh sorry, I'm so sorry. It's F plus 2, okay? F plus 2 by 2. Done? Okay, so now see, I can go for interpretation again. See here, we got this expression, right? If I know the degrees of freedom of monoatomic gas, I can easily find out the change in heat under isobaric process. Is that clear? Now you just see, what is F by 2 plus 1 into R? Just couple of minutes back, we got a specific heat under constant pressure. It was Cp or not? Cp was F by 2 plus 1 into R, right? So in place of this expression also I can write here del Q equal to N del T. Got it? If I take R, F by 2 plus 1 into R, then in place of this term can I write Cp? So ultimately I got del Q is equal to N Cp del T. Understood or not? I got N Cp del T. Del U was, now you got a new expression, okay? Del U was N Cv del T. But del Q change in heat will be N Cp del T. Please look at here also. Let me complete it. Also, I gave you one expression yesterday. Cv is R by gamma minus 1 in terms of gamma. Specific heat at constant volume is R by gamma minus 1. Is that clear? Now, also, in place of, first law of thermodynamics, in the equation of first law of thermodynamics, del Q is equal to del U plus del W. Understood or not? What was del U by the way? N Cv del T. And what was del W? It was NR del T. Yes or no? N Cv del T can be written as Cv is R by gamma minus 1 or not? Got it everyone? In place of Cv can I write R by gamma minus 1? Into del T plus NR del T. Is that clear? Just look at here, NR del T can be taken as common, right? I can write 1 by gamma minus 1 plus 1. This part is over, I think so. Over, na? Okay, so what I'll be getting here ultimately, del Q equal to nr del T, nr del T. If I take this gamma minus 1 here, got it, I'll be getting the LCM is gamma minus 1 only. 1 plus gamma minus 1, 1 get cancelled out or not? So ultimately what will be getting? Gamma by gamma minus 1. This is also one of the expressions. Understood or not? So from first law of thermodynamic, we can manipulate the expression of FLTD into multiple form under constant pressure. So the interpretation based on constant pressure is also over. It means isobaric process is over. Done? Let's complete the isochoric also. Please write. Isochoric process, the last thermodynamic process. Isochoric process. What is isochoric? The volume remain constant, right? Please write. The thermodynamic process where volume remain constant. The thermodynamic process where the volume remain constant. Is that clear? So how can I find the equation? The first interpretation is to find the equation or not. I am following the same pattern, okay, whether it be isothermal, adiabatic, isobaric or isochoric, right? So from equation of state, what was the equation of state? PV equal to nRT. Volume is constant. I'm just keeping P over here and bringing T towards the left hand side. Can I write nR by V? Got it? Since volume is constant, so P by T should remain constant. This is the equation of isochoric. Got it? Or for initial and final state, can I write P1 by T1, P2 by T2? Yes or no? Done? So we got P1 by T1 equal to P2 by T2. So try to understand now one more thing. You will be getting behavior of perfect gas topic, where you will be getting 3 gases law, important 3 gases law. Boyle's law, Charles law and Gay-Lussac law. Got it or not? The equation of these 3 laws are similar with the three thermodynamical processes: isothermal, isochoric and isobaric. For example, isothermal is similar with the Boyle's law. Understood or not? So when I will be explaining about the behavior of perfect gas, during that time you will be able to understand. You can relate the equation with all those gaseous law. Is that clear? Let me complete the isochoric at first. We have calculated the equation or not? Please go for the next interpretation. Work done. Work done under isochoric process. Work done under isochoric process. Under isochoric process. Okay, see here. What is the work? Work is given as P del V or not? This is the work under thermodynamical process, right? Now, for isochoric, change, volume remain constant means what? Change in volume need to be 0. Therefore, please keep in your mind, work done is always 0 in case of isochoric. Understood or not? In case of isochoric, I'll be going for the PV indicator diagram also, okay? I forgot to give you the PV indicator diagram of isobaric. No problem, I'll just give you combinedly. BCGS. Got it? For isochoric, del V equal to 0, so work done must be always equal to 0. ठीक है ना? Let's go for next. Specific heat. Specific heat. Obviously here also, oh sorry, what will be the specific heat? Specific heat at constant volume or not? Yes or no? Right, the specific heat at constant volume is, you need to mention the term, okay? Specific heat at constant volume is, what is that? CV, right? And what was the expression of CV? F by 2 R. Very good. For CP, F by 2 plus 1 into R. Is that clear? Don't forget, okay? Will you forget? No. Don't forget all this thing. Go for next. Modulus of elasticity. Bug modulus of elasticity. Please write the expression of Bug modulus of elasticity. Will you be able to calculate by yourself? Bug modulus of elasticity? Huh? Just think, na. Write the expression. Write the expression. What was the expression? B was minus del P V by del V or not? Got it? For isochoric, what you got? What is del V? 0. Therefore, Bug modulus should be minus del P V by 0. What is 1 by 0? Infinity. So what is the Bug modulus? Infinity. Got it? Let's go for the PV indicator diagram. PV indicator diagram. PV indicator diagram. Please draw the PV indicator diagram. Axis. See here. This is P and this is V, right? Yes or no? Okay. Let me, I want to draw the graph, the curve for the isobaric process. Then, this is the pressure axis or not? Got it? For isobaric, pressure should remain constant, right? Pressure should remain constant means what? It must be a straight line. Pressure will not be, changing over here. Only the volume will change. Is that clear? This is for isobaric. I hope you understood, right? Same to same you can apply for the concept of isochoric. This is P and this is V. Where should be the graph? Volume should remain constant. How it should be? Straight line, but towards the volume. Is that clear or not? Volume will remain constant here, no matter how much the pressure is changing, right? Okay, for today, this is the end of the class. I hope you understood, right? Is there anything you want to ask? Anyone? So we'll be solving questions in the next class. Thank you.